Hello everyone, this is Dr. V.V.Kamesh, Professor of Mechanical Engineering, Aditya University-Surampalem. In this lecture, we will start the discussion about how to find the velocity of the components in an epicyclic gate train. We will take one problem. The learning outcome for this lecture is, at the end of the lecture, student will be able to explain how to find the velocity of the components. See the problem. This is the fundamental variety of epicyclic gate train with only 2 gears, 1 arm, right. So, the gear A is having the number of teeth TA, gear teeth for the B gear will be TB, and in between the center to center arm C will be there. Arm means very simply a steel or wooden strip, right, simply attached at the center of A and attached at center of B, right. Now you can identify the problem. In an epicyclic gear train, an arm carries 2 gears A and B having 36 and 45 teeth respectively. So TA will be 35 and TB will be 45, 36, okay, 36 and 45. If now the conditions will start. If the arm rotates at 150 RPM in the anti-clockwise direction about the center of gear A, which is fixed, okay, gear A is fixed, it is one condition, arm rotating at 150, second condition. Determine the speed of the gear B. Now I need to find the speed of the gear B means simply I need to find NB, right. If the gear A instead of being fixed makes 300 RPM, that means we are going for second condition in the clockwise direction, right. So, the if part from here to here we need to calculate NB again. So, you can make it as NB dash, right. Okay, for the first one, if the arm rotates at 150 RPM and gear A is fixed, what is the velocity or the speed of gear B? How do you find? The most easy one is the table method. Now you can identify this. Okay, I will draw the diagram again. Okay, so this is A and this is B, and so in between I am having arm, right. Is it okay? Right. Now from this we need to write very clearly 4 steps, same to same procedure for every problem, right. The only thing is the components will change. There may have some next component. So as many components you go on increasing, right, but the first column will be step number 1. Definitely you are having only 4 steps, right. What is the second column? The conditions of motion. That means you are starting from primary level to the utmost level, right. So first one you need to make, the first condition is arm to be fixed, right. Now gear A rotates through +1 revolution, that is anti-clockwise, right. Why we need to have the same conditions of motion? It is the generation of the epicyclic gate train starting from simple gate train, right. So even though it is an epicyclic gate train, initially you need to miss the arm, forget about the arm, right. Then how do you forget about the arm? You need to fix it, right. When the arm is fixed, it is called simple gate train, right. When the arm is fixed, it is simple gate train. So first you need to write simple gate train equation for all the components. Then you need to modify one by one. So arm fixed, it is simply a simple gate train, right. So arm C. Now you need to make each and every column. How many components are there? First one is the arm, right. Gear A, gear B, right. Only 3 components are there in your system. So gear A rotates through +1 revolution anti-clockwise. We are taking the notation anti-clockwise is plus. Got it? Right. Now gear A +1, that means anti-clockwise. Automatically, due to the simple gear train analogy, gear B will rotate in clockwise direction where I need to put minus. So NB by NA is equal to TA by TB. Now what I need to find here? I need to find NB, right? NA is +1. Okay. Now this will be +1 into TA by TB, but the rotation for the gear B will be clockwise. So I need to put minus. So that's what your minus TA by TB. Actually, we need to write here NB is equal to, okay, so that somebody will understand what is this. NB equal to minus TA by TB. How it is generated? By means of the simple gear train equation, right? Okay. So first step is okay. Second step, in your problem you have given the arm is rotating at some speed or gear A rotates with some speed like this, right? So definitely we need to understand that either arm or gear A or gear B, they will not rotate at only +1, +1, +1 or -1, right? So definitely there will be some number of revolutions will be there. So the second step is multiplying with number of revolutions. So arm fixed, gear A rotates through +x revolutions. Earlier it is +1 revolution only. Whenever I am making the equation for 1 revolution, as many revolutions, same thing will rotate again and again and again and again, right? Now arm C, as usual, it is fixed 1, 0, right? Basically 0 into x I need to write here, right? So 0 into x is equal to 0. So instead directly we are putting 0, right? And gear A, so it is to be multiplied with +x, so +x. Now gear B, again it also rotates with the same number of x, so NB will be equal to minus x into TA by TB. Earlier it is minus TA by TB, now it is to be multiplied with x, very simple. So whatever the items are in step 2, they are simply a multiplication by x to all the components or equations in first step, right? Okay. Now the third step will be the common again for all the problems. Add plus y revolutions to all the elements. Why we need to add the plus y revolutions? When arm rotates, it will rotate the entire system, right? That means when arm is fixed, so the entire system will behave in its own, right? Now when the arm is rotating, so the total system will be run along with the arm, right? Now arm will be plus y, gear A will also have plus y, gear B will also have plus y. So what is the total motion? Arm C. So the fourth step will be a summation of 2 plus 3, because I am having the normal behavior of the gears or gear train will be defined in the step number 2. Add plus y revolutions to all the elements, it is the part of arm, right? Now arm C will be plus y, arm A will be x plus y, gear A will be x plus y, gear B will be minus x into TA by TB plus y, right? Now this is the final items. This is for arm C, this is for gear A, and this is for gear B, right? After finding the final equations in the fourth row, then we need to go back. What are the conditions given? Until then, we need not worry about what is the condition given, what I need to find. Finally, we need to find the velocity only, right? Okay, what is the condition? Arm rotates at 150 rpm, okay, right? So arm C, so this will rotate at 150 rpm, right? What is this? Anti-clockwise. So anti-clockwise means plus. So y is equal to plus 150 RPM. It is equation number 1. You can write. Second, gear A which is fixed. That means gear A velocity will be made 0. So what is the gear A velocity here? X plus y. So I need to make x plus y is equal to 0. Already this is the second equation, let it be. So gear y is equal to plus 150, first one, x plus y equal to 0, second. So automatically I can find x is equal to minus 150 RPM. So x equal to minus 150. So thereby what I need to find? Determine the speed of gear B. What is the speed of gear B? Y minus x into TA by TB, right? So what is y? 150 minus x. X is minus 150 into what is TA? 36. What is TB? 45. Right? Now after finding, then you can have the equation. When the minus and minus are being cancelled, 150 plus 150 into 36 by 45. So finally we got plus 270 RPM. Whenever I am saying the plus means it is clockwise. Okay, plus means it is anti-clockwise we are taking. Right. So B will rotate in anti-clockwise direction. Okay. There is another condition given in the problem. If the gear A instead of being fixed makes 300 RPM. Okay, look at this. We will write the equations here directly. Arm will be plus y, gear A will be x plus y, gear B velocity will be y minus x TA by TB. Okay. Now what is given here? Just look at the statement. If the gear A instead of being fixed makes 300 RPM, okay. So x plus y is equal to 300. Okay. X plus y is equal to 300. So the only condition of the gear A is changed. What about the arm? Arm rotates at 150 RPM anti-clockwise. So what is the arm rotation? Y is equal to 150 anti-clockwise. So y is equal to plus 150. So automatically by the equation x will be equal to plus 150. Then what is the speed of gear B? Now I need to find NB dash, y minus x into TA by TB. So y will be 150 minus, again x is 150 into 36 by 45. You can find very easily. This will be equal to 150 into 45 minus 36, 9 by 45. So this will be 15 into 10, 15 into 3, 3 into 3. So this will be 30. So NB dash will be equal to 30 RPM. Because I am getting plus, I can call this as still anti-clockwise, right? Okay. And you can remember one thing, whenever in the first equation the NB is positive or negative, the same sign will be forwarded to second condition also, right? Okay. This x plus y equal to 300 if it is anti-clockwise, okay. Okay, right, you can find this. Two conditions we can apply here. It's a better one, I think. Anti-clockwise direction plus 300. If it is clockwise, then I can find the equation simply like this. X plus y is equal to minus 300 and y is 150. Okay. Then I can find x is equal to minus 450 RPM. Whenever I am saying minus means it is anti-clockwise, then NB will become 510 RPM anti-clockwise, right? Okay, you need to read the problem carefully, like whether you are making clockwise or anti-clockwise, right? The same problem you can find two different equations, right? So the summary of this lecture is student can calculate the velocity of the components of the gear trains under given conditions. Thank you.